So why is Z called the compressibility factor or the compression factor? Well, let's see. Z is equal to PV over nRT. So let's compare an actual gas, a real gas, with the gas if it were behaving ideally at the same pressure, temperature, and number of moles. Okay, let's compare the volumes. So Z, okay, for an idea for a real gas would be pressure times volume over nRT, and this volume right here is the real volume. Okay, that's just PV over nRT. Now, if it were ideal, then Z would be equal to 1. So pressure times the ideal volume over nRT would be equal to 1. Okay, so what can you show from here? Z is equal to what? You can show that Z, let's divide Z by Z ideal here. Okay, what do you get? So let me write this down here. Z equals PV over nRT, okay, over Z ideal, which is 1. PV ideal over nRT. So at the same pressure and temperature, okay, same number of moles, R is a constant, Z over Z ideal is just V over V ideal. Okay, but Z ideal is just 1, so Z is really just the ratio of the volume of the gas for that temperature and pressure. You compare the volume of your gas that you measure, compare it to what you would calculate as the volume of the gas using the ideal gas law. Using PV equals nRT, calculate the volume of the gas. That will give you your Z. Here's another way of looking at it. The ideal volume, okay, since PV ideal equals nRT, the ideal volume is equal to nRT over P, right? So you can say then that Z, which is PV over nRT, you can write that as volume divided by nRT over P, right? All I did was I would divide both numerator and denominator by pressure. But what is this down here? That's the volume you would calculate if the gas was behaving ideally. So in other words, this is the actual volume divided by the ideal volume. So why is Z called a compression factor? Because it tells you how the volume compares with the ideal volume. So if Z is less than 1, what does it mean? Then the real volume is less than what you would expect if it were behaving ideally. If Z is greater than 1, then the actual volume or the real volume is greater than or bigger than what you might expect if the gas were behaving ideally. Okay? So let's illustrate that. 1 mole of a gas sample at STP has a molar volume of 22.0 liters. What's the compression factor? What's my Z? It's equal to what? PV over nRT, right? Or it's equal to volume over volume ideal. What's the volume of the gas given here? 22 liters. What's the ideal volume of a gas? If a gas is behaving ideally at STP, what's the volume? Do you remember? Volume of an ideal gas at STP. 22.4 liters per mole, right? Okay. So if you don't remember, you can plug in V ideal here. V ideal is nRT over P. And this will come out to be 22.4 liters. We're dealing with 1 mole, so let me get rid of that. Okay, so it's just 22.4 liters. So liter cancels out. And what's my Z then? What number would that be? 22 divided by 22.4. So that's going to be 0.982. So your compression factor is, or compressibility factor is 0.982.